Okay, so in 10.2, something we call as a specific heat capacity. Okay, what is exactly a specific heat capacity? If you want to like put it into a simple layman term, understand the definition. No, that you can never run away from the specific capacity definition. So, what is the definition for the specific capacity? It's basically amount of energy required to increase 1 kg of substance by 1 degree Celsius. It is so scientist, right? Yeah, no choice. These are the terms. Let me put it into a layman term. What is the meaning of specific capacity? Now, imagine there will be 2 cups here. Okay, cup number 1, smaller. Cup number 2, bigger. Okay. Specific heat capacity tells us that how much of the energy that you can store to increase 1 degree Celsius. Logically thinking, we can say for this one, I'll write short form here. This one's specific heat capacity is smaller. Smaller. This one's specific heat capacity is bigger. So what is this definition tells us is, if I fill up the water here, when I fill it up completely full, then I will increase 1 degree Celsius. Same thing goes to here. If I fill up here completely full, I will increase 1 degree Celsius. That is what you can think of it like a specific heat capacity. So what is the generalization that I want you guys to understand here is that when your specific heat capacity is smaller, that means that you will increase temperature faster. Why? Because easier to fill up, smaller, easier to fill up. So therefore, you will increase temperature faster. When the specific heat capacity is bigger, that means that increased temperature will be, this is faster, this will be, yes, slower. So a lot of people will always think that, oh, faster is always the better. Not all the time. It has to depend on what are the things that you are looking into. Like, let's say, for example, let me just give you a real situation. Let's say this is a frying pan. So in terms of frying pan, we have 2 components. We just classify into 2 main components. Number 1 is the pan itself. Number 2 is the handle itself. Okay? Logically thinking, do you want the handle to be hot faster? No, we want it to be hot slower, right? If I want to make this temperature slow to increase, do I want the specific heat capacity here higher or lower? I want to increase. Yeah, so therefore, in this situation, I want the specific heat capacity here to be higher so that it heats up slower. When it heats up slower, when we hold the handle, we will feel the heat. Whereas the pan itself, we want the specific heat capacity to be lower so that you can cook the food faster. And if you still remember, in order for us to cook the food, what is the term that we use in order for us to cook the food? We call it a thermal. How do we steam the fish? It's always under thermal equilibrium. Okay. No? Don't remember. Okay. Thermal equilibrium simply means that when I put 100 degrees Celsius and 0 degrees Celsius, when I join them, it becomes 50 degrees Celsius. That is thermal equilibrium. So in order for you to cook the food, I heat up the pan already, right? I put the food on it so that the pan will transfer the heat to the food. That's how they cook the food. That is what we call it as a thermal equilibrium. Okay, I get it up. So now you know what is the specific capacity already. The next things we have to go into the formula. The formula, it will be I might give you a little bit like different arrangement. Let me show you the one that's given in the book first. The one that given in the book is C is equal to E over M theta. That is the formula that's given in the book, okay? But in order for me to make it easier to understand, I would say that E is equal to MC theta. I prefer you guys to remember this. Why? It's because that this C stands for specific heat capacity. If you want to find specific capacity, then you use E over M theta. What is the E, what is the M, what is the theta? I'll use these formulas to explain you. The E here stands for energy. It means that how much energy for you to cook. That's E. What is the M? The M stands for mass in kg. The C stands for specific heat capacity. And this data here, we call it as change in temperature. That is how we utilize this formula. You notice that if I want to find C, I have to move this 2 to the bottom. It's exactly the same formula. So I'll prefer you guys to use this formula rather than this formula. It's much easier to see. So in order for me to calculate like this kind of stuff, how do we apply it into the questions? Let's say for example, if I have water. Let's say the water is 10 degrees Celsius, okay? And then I give you that this water, let's say, is 5 kg. And I give you specific heat capacity of the water is about 4,200. That is the general rule of specific capacity. Okay? If you want to know the unit, let's take a look at here, people. What is the unit for energy? It's always in joules. What is that? What is the unit for M? Kg. What is the unit for temperature? Degrees Celsius. So if you want to see the unit of the specific heat capacity, it will be joule per kg per Celsius. You can write it like this, or some people they write it like this. That means the same thing. You see, joule divided by kg and Celsius. That is the unit for this. Okay. Now, what if I ask you, how much energy do I need in order for me to increase from 10 degrees Celsius to become 80 degrees Celsius? How much energy I need to heat this water so that it reach 80 degrees Celsius? We can use this formula to help us define. So according to the formula, we know that C equal to MC theta. And I want to find my energy so that my mass of the water I give you is 5 kg. Specific capacity usually is about 4,200 for water. And then the change in temperature is 80 minus 10. So when you press this into your calculator, you should be able to get your answer somewhere around 1.47 million. So it's about 1470000 joule. If you want to change it become a kilojoule, can you? Yes, of course, you can change it become 1478 kilojoule. That is how we do for the specific heat capacity. Okay, yeah. That is the 10.2 that you guys need to know. So important definition, you need to always remember. Definition you need to always remember, and then you need to understand the concept of specific capacity, and then the formula is important. So these are the two. I will stop and yeah.
Could you explain thermal?
Okay, thermal equilibrium means that whenever there is something at 100 degrees Celsius, let's say my right hand is 100 degrees Celsius, my left hand is 0 degrees Celsius. When I combine them, eventually they will go into the same temperature. When they hit the same temperature, that is thermal equilibrium. Thermal means temperature. Equilibrium, it means balance. So that these two balance out. We call that as a thermal equilibrium. As long as, yes.
Temperatures cancel.
Not cancel when the temperature is the same. Then we call it as thermal equilibrium. Okay. If you want the keyword in thermal equilibrium is net heat flow is 0. Because whenever I have one higher temperature, lower temperature, the net heat flow is always from the higher to the lower. Once both of them reach the same temperature, is there any heat flow in between? No. Therefore, it's the same net heat flow. All right, I will stop recording, take a photo and send it.
Wait.
Yeah.
Why do you use theta instead of like t?
Yes, you can use a theta, you can use a T, it doesn't matter. Because a capital T, usually they use it for the temperature. They use T when they write it like this, Jiaqi.
Can you use a triangle here?
Yes, yes. They only use a T, they add a triangle. So they can change this become a triangle T, yes. But you cannot just write pure T, cannot.
Then
Cannot write like
because-
MCT, cannot. But when you want to write the T, it must be MC change in temperature like that.
But then you use theta is like something to do with tangent almost.
Not really. In physics, in this data here is referred to the temperature, change in temperature.
Okay.
Yeah. The one that in the tangent one is referred to the maths one, but this is physics, so they separate one another.
Then do I have to remember the what? 4,200.
No. This one you need to remember. This one is in general for water. You don't need to remember. As you progress, when you see much questions, you'll come to you naturally.
Okay.
Yeah, you don't have to memorize the number. No need. Whatever numbers that you don't have to memorize. Whenever I ask you, whenever the number need to be memorized, I'll let you guys know that you guys need to. Okay.
Okay.
All right. I'll stop recording. Take a photo and send it.